I think so. I, I hope everyone saw my presentation from yesterday. Towards the end, I started to mention about the upstreaming the project. So this is quite a big part. I've been cleaning up the code, and we're looking at a couple of hundred patches, 17,000 lines of codes with the POC at the moment. So it's not going to be merged in a day. It's not unlikely going to be merged in a week. So I wanted to start discussing on how we can split what would be acceptable as a first part on any interest of participating for the upstreaming. So I guess the first question I guess some of people will wonder, most of the code has been written in Xen. I've seen discussion at the beginning, when was it, a couple of months ago, about moving that outside of Xen. The main problem is most of the information we need are in Xen. So what we will end up to do is just doing an hypercall to Xen for getting the information from back to the domains. There's also information that we need to transfer, like the M2P, some state of free memory, etc. from Xen. So there is some information we definitely need in Xen.
So one thing on that point specifically, as you were going through your talk, I had an idea. The M2P is a fixed structure. The format and layout are fixed. You don't, just like you don't need to move domain memory, you don't actually need to move the old M2P.
We don't move it, actually.
All you need to do is find the page table pointer at the top of it.
Correct. We don't move on, we can't actually moving it because DOM0 may have mapped it.
Oh, yes, so you're going to have to do it in place, aren't you?
Yeah. So that's the main thing. The idea of what we would show for Live-Update is that there is no help from DOM0 or any domain. DOM0 is kind of in a gray area because it's a PV guest, so we kind of kept the door open of if we want to, if we need DOM0 to be in the stories, then we will try to do it. But the best we want to do is not help from any domain at all. So we don't have the problem of, oh, we need to wait this domain to answer, which is one of the major pain points with the live migrations today. It also means there is a whole lot of state to transfer, like the event channel, the ground table, the IOREC, etc., which at the moment we're looking at probably 50 plus new records. And I'm looking at you, well, I'm thinking about you, Andrew, because I know that you work quite a bit on the live migrations. The idea is we want to build on top of live migrations. We don't want to create something different, or maybe domain context that Paul has been doing. So domain context is the same as the HVM context, except that it's been more generic, so it can cater PV or any generic records that will not necessarily fit in HVM records.
So the reality is that the HVM records are in a terrible state, as are some of PV doesn't even have records in a stream. There was a logical next step to migration that I never got around to, which was to do a similar thing. A similar thing as we did at the libxc and libxl level, that did that was a stream for an individual VM, which would replace the current HVM stuff and replace the PV stuff, and replace it with something that wasn't a complete and utter disaster to parse in the hypervisor. I don't you've presumably looked at that code, and you presumably would agree with me that it doesn't look as if it's the safest parsing code in the world. For anyone listening who hasn't looked at that code, it is entirely full of pointer casts all over the place. It's rather terrible. The compatibility plan I had, so the plan I had originally for this was to do the conversion of the old style into the new style in user space, similarly to how we've got the convert legacy to v2 stream script. Having a stream that is essentially a representation of a single domain, I think, is a useful primitive for you as well. Obviously, you'd have. Okay, we call it a stream, but it's one logical block of data that refers to stuff for this individual virtual machine. And yes, you'd have multiple of those in a row in the Live-Update case.
Correct. So the same is very similar to live immersion. The main difference is that we have at the beginning we just have a few records that are global for Xen, like the M2P, etc. And then everything else is then you have a domain, and then you have the next domain, etc. until the end. So it's pretty much the libx system with a few more records in it.
Yeah, there's always going to need to be some kind of global state here, and so long as that is safely contained in a sensibly extensible spec, then that should be fine.
We try our best to not do the other records tied to Xen. Have to say that, going inside Xen, within the code, diving deep in some part of the code, there's some weird things we found. So most of the records are meant to be on the goal is to not be tied to a version of Xen. So you could, for instance, migrate from 4.11 to 4.16 without any trouble in theory.
Yeah. So
practice,
we want to come up with some clean architectural representation of the state. Now, for HVM guests, there are some fairly good ways of doing that, and it is not how the current HVM stream works. Obviously, when we get to things like the Paravert devices, that becomes more complicated. But we still want to invent some kind of version neutral ABI for serializing and deserializing the state.
So our idea was to base everything on hypercall. So what we want, most of what we do is re-evaluating. It's not re-evaluating the hypercall, is that we redo the hypercall on the next end. So most of the stream is similar to what a guest will do in terms of hypercall, but in a structure idea. So for instance, go on.
I'm confused by how that works.
So let's give the example of the event channel. When you create an event channel, you say that this is the interdomain, this is my, and then you may do a second hypercall about the priorities and the vCPU, etc. So we may have a record that's storing the event channel, the port, which priority it is on which vCPU, but what we do at the end is calling the 3 helper one by one. So we recreate the domain as it would do itself to avoid too much coding then on too much modification.
How do you do that for DOM0? Because DOM0 isn't running at the point that you need to restore DOM0's event channels.
But we can recreate DOM0 from then. When I say redoing the hypercall, it's just then we'll do it on behalf of the domain. It's not like we're going to do it from the domain itself. There is no cooperation here.
Okay, so what you're saying is you've structured the state in the logical way the guest would have to use hypercalls to set it up in the first place, but you've just got the stream available in the hypervisor and you're calling functions.
Yes, that's correct.
Okay. How extensible is that? Because the thing is, things will change over time. Certainly, if we're looking at the grant tables, and several people have already banded around a question saying, can we invent grant table v3 to try and fix things like the 16-bit atomic problem? So long as what we're doing ought to be compatible with future extensions like that, I think it is probably okay. So long as the stream is forward extensible.
It would be a mat. So either you will be able to use the same record, or you will be able to create a new record. Most of the stream, most of the pads are res 0 to avoid any forward problem. Pretty much anything is version. The stream is versions.
That's all probably fine.
I think the main thing is why we base on the hypercall state rather than inside Xen itself is because most of the hypercall are meant to be stable. Aside dumcuttle, everything that we expose to the guest are meant to be stable, and in general, we should not need much more than what the guest has been doing. There's a few instances where we may need a bit more information than what the guest provided, but it's pretty rare in most of the hypercall. Like for the event channel, we can transfer exactly what the guest requested.
Yeah, and that's probably actually better anyway. For recreating something on the far side.
So that's the way we did the safe part. The restore code is, I guess, the most interesting part because there's dependency between domains. That's sort of the bit that is probably will spark some debate on how to do it. So the way we decided to go with it is having multiple paths. So we have three paths at the moment. That's going through all the records. The first one will create a domain. So that's very similar to dumcuttle create. It may restore the P2M for the HVM because it's necessary for some of the bits. The second one would restore the second path will restore things like memory. And the third one will restore most of the things. The idea is that in each path, there is no dependency between each domain, but there may be dependency between path 2 and path 3 for a given domain.
So I totally understand why you need to separate creating the domains out into a first pass. What exactly are you doing there? Is it only domain create, or is it domain and vCPU create?
Domain and vCPU create.
Okay, so there's one slight problem there that is currently pending on the list. In current and future Intel processors, the size of the Xsave state is getting stupidly large. So there is the architectural LBR at 1.5K and the ANX tile state at 8K. So the proposal that we've currently got is that it would be expected for there to logically be a set CPU policy hypercall in between domain create and vCPU create. And the current plan was to enforce that, to apply some enforcement of that in the order of hypercalls. during domain create. Because the thing is, you have to get that right before you can allocate the correct size data structures when allocating the vCPUs.
Well, one possibility would be to split that in 0.1 and 0.2 or something like that.
Yeah, so for that, all you would need to do is move the domain CPU policy, and that's already available in an architecturally neutral format. So the requirement there would be to split up slightly where your boundaries between the three phases are. But the domain CPU context is specifically something that is fixed and constant from the moment the domain was created. So it's mostly the CPU ID data and various read-only MSRs that control how the VM behaves. So it's all static information as far as the construction of the VM goes. It's not dynamic register state.
Okay.
So that would need to move into phase one, but I don't see any conceptual problem with doing that. Why do you need to do the memory differently?
Because we need to restore the file mapping on knowing exactly the number of reference. So like, for instance, let's say that you have DOM0 that has a mapping on DOM A. You need to restore the memory for DOM A before mapping the memory, because you need to get a reference, and most of them doesn't work without a domain. It needs a domain to get the page. If there is no domain, the page is considered to not be able to get a reference on it.
So where are these references coming from? Because it's not a problem for DOM0 because you're leaving DOM0's page tables fully intact. Presumably, you're talking about a reference in an EPT.
Page info.
Sorry?
In the page info, the page count. What I mean here. We need to restore the page count. We don't transfer the page count because it may change between then.
Yes, that's fine. But you need to get back to the same number of references you had.
Yes, that's correct.
But I don't understand why splitting the memory helps you there, because presumably in your simplified system you've got a DOM0 and maybe a couple of other helper domains that are the privileged thing, and everything else is unprivileged. In an arbitrary Xen system, you could have arbitrary foreign mappings of each other, but surely you can only do that by reading the old EPT or MPT tables and identifying foreign mappings.
Yes, but how do you grab a reference in Xen? You need that page to grab the reference. You need to know the domain.
So what you need to do is restore the domain ownership information in the frame table before
being able to restore the reference for the foreign mapping or the ground table.
So I think this is where Christopher was asking the question. So this is the same problem we have effectively in Hyperlaunch in terms of constructing all the domains at startup. So that was the approach. That's why we came up with the boot domain to handle all the sequencing and getting mappings put in place and everything else. Could something like that be leveraged here?
I think ultimately the requirement here is to be able to live update without an interruption to the system. Of course, there's going to be some interruption to the system, but you can probably tolerate a few hundred milliseconds, and you can't tolerate several seconds.
we'll look from what we said a couple of years ago. We're looking at less than 2 seconds or 2 RTT. We don't want the guest to see like a network connection drop or something like that, SSH drop, etc.
Yeah. Okay. So 2 seconds is a hard upper bound on the amount of critical downtime here.
Yeah.
And the reality is, I think I said this at the time. I think we could reasonably get to several hundred milliseconds with a bit of care. Maybe not in V1, but I think there are enough things that can be organized ahead and behind time that the critical section can get down quite small. But yeah, I guess the thing with the boot domain is that essentially this is a real-time problem. You almost certainly cannot afford the overhead of running the boot domain and have it make decisions, because amongst other things, you're wasting a lot of time on context switching between user and Xen at that point. So yes, a boot domain would allow more flexibility to do this in more complicated ways, but I think the overhead is going to be prohibitive.
There will be also a lot of hypercall to recreate unless we pass a blob from the boot domain to Xen, but then there is not much difference from doing the blob directly in Xen.
Yeah, and at the point you're basically passing a blob and letting Xen do all the hard work, you might as well not have the boot domain in the first place, because at that point it's just overhead, almost. So I think when it comes to the reference count, I think I can see the problem that you've got. I'm not quite sure I can visualize quite how it is worked around, but I can certainly see that it is a problem and it's not trivial.
I'm planning to share some code in the next, hopefully in the next month. I've been cleaning up the codes, so that may be easier to understand some of the problems. And we have exactly the same problem with ground table, is that for restoring ground mapping, we need to know this is a ground mapping, because the way we do the referencing then is completely different to foreign mapping. It's been a bit of a nightmare for us to do it. In our POC, we just flagged the entry as ground in the PV sides, which I think is a bit ugly, to be honest.
I have to admit I'm not happy with how the reference counting works here generally. Obviously, this doesn't help your problem, but I would like to see about doing something less terrible in future versions of Xen. The reference counting logic we've got is far too complicated and far too subtle.
I won't disagree. Been diving into that code. Yeah. So I think the first thing is that would be great to get some. There is a design document on the mailing list. I would recommend to read it. It's probably not as long as Hyper Launch yet, but it contains some useful information on how we envision live updates. That would be the first start to decide on that. I think the way I can see forward is starting to get some bits and pieces for live updates, like the live update memory, how we relocate Xen, etc. Merged, and then we can start about down zero on possibly HVM afterwards. I'm sure there will be some cleanup along the line on possibly some records that we may need to add as making properly upstream. The main things actually in our POC is that it only works with Intel so far, so no ARM support, no AMD supports. The support for guest, there is no guest PV supported. There is HVM, but no shadow page tables. there is no VPMU. There is some sort of support for the IOMMU, but as there's so many states, I think what I would like to see at the beginning is just trying to restrict to specific configurations, and then we can add on top for other configurations.
Absolutely restrict the problem to a minimal subset first, because even that's a large amount of work. Out of interest, I'm not saying go and do AMD support. What things are missing for AMD support?
The IOMMU, for instance, support on.
Oh, so this is the logic to take over a running IOMMU.
Yeah, we haven't tested anything on AMD yet.
Okay, so the other areas where you're likely to see issues is, so the VMCS and VMCB are different. Intel make this irritatingly hard, and AMD is lovely. AMD is just a shared page in memory. You can honestly just pass a pointer to it if you want.
We shouldn't need to transfer that technically, because all the guests are paused, so we can just recreate it as we will do in
that's
live migrations.
Yes,
at least
you're
I
right.
hope. I haven't looked at the codes to confirm that.
The other thing, depending on how you move the M2Ps, the MPT page tables have a different format to EPT page tables. The metadata is still the same in them, but the pointers are the same in them. The metadata is different. So depending on how exactly you've sent the P2M, it might need a bit of a tweak to know if it's looking at an EPT P2M or not.
The P2M is somewhere we kind of break the idea of we want to keep it agnostic, because if you do pass through with IOMMU, you need to keep the page tables around, because you can't query the device. So the P2M is transferred as this. I know there might be some.
And what do you mean transferred as is? Do you pass a pointer to the top of it, or
a pointer to the top of it? There is
okay.
We transfer the pointer to the top of it, plus we transfer each page, so we know where we don't have to work the P2M to restore it. But the content is the same. The main reason is that for the IOMMU, you need it because you can't query the device.
Okay, that makes sense. So on AMD, you have to be aware that the P2M has metadata in different places. But to be perfectly honest, for Live-Update, you can make the assumption that it was written on the same hardware that you're currently running on. So you can say if Intel do EPT, else do MPT. And exactly the same would be true for shadow page tables. The P2M in the shadow page tables is NPT. Again, metadata lives in a slightly different format. So I don't think there's actually a problem doing shadow page tables like that. The actual shadow memory themselves, you can totally throw those away. The shadow code will recreate them from scratch as the guest continues executing, which is how the shadow page tables work in the first place.
That's actually pretty good to know that.
Yeah, and the shadow page tables have always come out of a pool of memory, and when you run through them, they get recycled based on a least recently used list. But the way this works for PV domains, when you try and migrate a PV domain, we just turn shadow on, and it recreates the shadow page tables from first principles as the guest continues to execute. Now, of course, for an HVM shadow domain, you can't just turn shadow off, because then the thing will malfunction. But there is shadow drop all tables, I think, is one of the calls into the code, which will literally destroy all shadows, all reference counts, and restart from CR3 and build it up one fault at a time.
Okay.
So you'll need to pass the P2M. just like you need to for HVM guests, but I don't think that there will be any further complication there.
Okay, I'm not sure we will have a look before upstreaming it, but that's good to know for the future.
Yeah, I think in reality it probably means you don't need to make everything quite so EPT specific in the first place. Obviously, I'm not saying go ahead and definitely make it work with all three before posting code, but what I mean is I think you can get away without making it so specialized to begin with, and the others might just work. So that might be easier.
Yeah. Okay. So I think the main difficulty with Live-Update, and we discovered it when we did with the POC, is there is no way to know it works until you have everything set up for DOM 0. Even if you miss like a bit of it, it won't work, unfortunately. So I'm wondering how we can merge that upstream with, well, there might be some dead code at the beginning, or is there any way we can make it useful from the beginning to test it?
So
I don't really understand the question. So what is it? What is it you mean?
I think I know exactly what the question is getting at. Certain maintainers insist that no dead code is added to the tree.
I see.
I think the reality is that here we know exactly what the long-term goal is, and even if it's starting to put in hypercalls to begin with that are maybe just stubbed out, I'm perfectly happy with that going in. And we understand this is a massive quantity of work. It's the kind of thing that might want to start with a kconfig option originally, particularly if it's fairly invasive to start with.
It's pretty self-contained, actually. We managed to get everything in a couple of, in a few files, in a separate directory with a bit of hook in the command codes, but there's not much actually.
Okay, we probably still want a kconfig anyway for it.
We have a kconfig,
yeah.
In any case, even internally.
In which case, I don't see any issue with that at all.
Okay.
Yeah, we've got lots of, like there's ARNC, there's like all kinds of stuff. I mean, particularly if it's pretty self-contained in its own separate files, then there's a pretty strong argument to say it doesn't need to have the same degree of fine-tooth comb, picking over it. But
will it be sensible to start with just DOM 0, no guest at the beginning? Is it something that would be fine?
I think that would be entirely fine.
So.
Yes.
I'm not sure it's reducing a lot the codes, but it might just be enough to do something.
It's much more likely to be something that you can get to work at first.
Okay.
One question, seeing as we're starting to run out of time, on the subject of emulation, do you have any work there yet?
I'm not sure what you mean.
The emulated instruction boundaries.
We stop the cast the same way we do a pause for migrations.
Okay,
I know it's broken.
You call domain pause on them, and then okay.
We don't call domain pause. We call something similar to the pause from the libxl, because the pause from libxl will stop the vCPU at theoretically a safe way. I know it's not the case from our past discussion.
Well, the hypercall is domcuttle pause and unpause, but I thought that it uses domain pause by system controller, but all that does is cause it to take a second reference.
it's also there is a it's a shutdown dereferral. Sorry, it's not. We shut down the domain for migrations. I forgot about it. Sorry, which is a bit confusing.
The shutdown deferral. To be perfectly honest, I've looked at that code several times and not completely convinced it does anything in the first place.
It does prevent the an IO to be in flight, because we had some issue with not doing that. Whether it works for everything, that's a different question, but it works.
Well, that was the other thing. I looked at it and said, that's fine. This is potentially fine for one case, but there are plenty of cases that it doesn't cover. I think we probably need some tightening up of that code, but again, that should be fairly easy and self-contained, I would have thought. In particular, I suspect we have actually hit issues around that with the introspection work we've done, because introspection in particular cares about pausing individual vCPUs for a while, and that we had a huge set of problems with updates without basically taking the vCPU out of context. So I suspect we have actually encountered those bugs before and bodged around them in nasty ways.
Okay. Yes.
What do you do about physical interrupt bindings? Or is that still on the to-do list?
No, we mask the interrupts on the epic is reset by the Xen 2.
So you presumably you mask it at the IOMMU?
We must. I can't remember exactly what we did. Mahir, do you remember where we masked them?
So yeah, for MSIs we set the masking bits, and since they bypass IO APIC and all, I think we do it on IMMU. Was that the question?
So the Xen, the current code in Xen has some incredibly stupid things it does when both an IOMMU, when an IOMMU is present and other aspects of the system are. I suppose what matters is that the interrupts don't appear.
Yes, and we haven't really seen any incompatibilities with the IMMU itself, as long as the descriptor is masked.
Yeah, masking them at the IOMMU is the correct way to do this.
We found a few funny things, like for instance, when we do the kexec bits, when it restores when it moves the interrupt, it will mask the interrupt and then unmask it, and that's an unconditional unmask. And because we don't get any reference in then about the number of times we disable the interrupts, and the interrupt will come up again. And we had some funny bugs with it where we spent a few weeks finding what's going on.
Oh yes, I was thinking about the IMMU aspect, but yeah, mask them and we save and restore the masking bits, reapply them as they are in restore part, and except for the corner cases Julian mentioned, it seemed to be working fine.
Okay.
And that's for MSIs. For pin-based interrupt, there's not much we can do.
I think for pin-based, for GSI, the kexec code will disable all the epic, so all the interrupts should be masked.
Yeah.
What we need to be careful is it's quite likely we need to set them pending after the boot on the Xen 2, so after the live updates, because we may lost some of the interrupts.
You shouldn't lose any line interrupts. You just leave them masked in the IOA pick.
I have one question related to the interrupts. Do you see any issue if there is an interrupt in progress in Xen 1 and we don't transfer the in progress in Xen 2?
That's complicated because I think the code, the interrupt handling code is several orders of magnitude more complicated than it needs to be. I think you probably want to mask all interrupts, ideally at the ILMMU. Oh, actually, slight tangent. What preconditions are you restricting to here? Are you going to attempt to support systems without an ILMMU or not? I think at this point it would be entirely fine to say we don't support old systems and restrict to something quite new.
We will support without on with IOMMU. Okay,
so you explicitly plan to support the non-IOMMU case?
Yes.
Right. Okay. That's fine. I just wanted to check. Okay, so you probably don't want anything. You almost certainly don't want anything in progress in Xen whilst this is going on. Because anything that's in flight in Xen is going to be a nightmare to deal with. You want to mask all the external interrupts, then wait for everything that is currently pending or currently in progress to no longer be in progress. So long as the interrupts get marked as pending in the either in the event channels for a domain or in the emulated IOA pick for the domain, then you're fine, because then that state is preserved.
Okay.
But yeah, you want to mask everything at the hardware level, let things filter through so you're not running any interrupt handlers in Xen. Then you want to save state. And at that point you should have picked up every in-flight interrupt. Then you do the update, then you just resume the VM, and it will find in the virtualized APIC state some more interrupts in progress.
Okay. Yeah. Okay, makes sense. I think we are running out of time, unfortunately. Is it 7, the end of the meeting?
Yes, I think it is.
Unfortunately. Would it make sense to have any, like maybe monthly call about live update on diving deep on some of the bits as we go merging in upstream?
If it's not, I mean, if the things you have to talk about aren't too long, you can think about bringing it up at the community call. But yeah, if it's going to be more than like maybe 20 minutes a month, then probably want to have a separate.
I'm sure there will be some technical bits that will need probably in conversation between Jan, Andrew, Roger, and I on quite deep technical bits. But
in which case, yes, we probably should have some kind of meeting set up for that.
Okay. Yeah, so my next step is to refine the design documents, posting some codes, POC, and we can start from there about the upstreaming.
Okay.
Yeah. Thank you everyone for listening.